Hi, everyone. To anybody who I see is currently getting disappointed, that QR code does not go to the slides, but you can find the slides linked on my website, which is joshuakgoldberg.com. I'm also Joshua K. Goldberg on Twitter, the Mastodon server Fastodon, Blue Sky, Twitch, YouTube, and I think Reddit. Not Reddit. Anyway, hello again. I'm Josh. You might recognize me from my talk yesterday on striker mutation testing. This is not going to be about that. This is going to be about the stuff I actually do day to day, which is TypeScript. Yay! Now, from what I understand, this conference is like 70% .NET people and 30% everything else. Just show of hands, who here's a .NET developer? I was wrong. It's like 97%. Who here is not a .NET developer? Wait, that math doesn't add up. Someone is lying, or it's Schrodinger's development. But thank you for coming, I appreciate it. .NET, or rather the more popular language within it, C#, is a really cool language I used to work in a lot. And a lot of the language features in TypeScript and C# actually were informed and learned by each other. C#'s async await, one of the best things in my life ever, was a big inspiration for how JavaScript async await developed. And then the relatively newer null ability in C# was heavily inspired by a lot of modern languages such as TypeScript, having or null and types. So regardless of whether you're a .NET person or the other three people in the room, this is going to be relevant to you. Yay! Yay! Okay. One last note before we begin. I understand that it is impossible to give a good talk for everyone. There are people who know type systems and type theory and have implemented TypeScript type system shenanigans, and there are people who've never seen it before and don't know why we keep talking about it. This talk is optimized for the people who've never seen it before and don't know why we're talking about it, but it will still be relevant and applicable if you do know what TypeScript is. But if you want a deep dive, come find me after. We ready? Yay! Could I ask the people coming in, could you close the door, please, if you don't mind? Thank you. Appreciate it, helping me out here. All right, TypeScript. Why won't tech X shut up about it? TypeScript, I'm going to give you a few definitions to see which one sticks. TypeScript is a superset of JavaScript. Here we mean superset as in it is all the syntax you know and love in JavaScript, along with a bunch of extra syntax, ways to declare types. There's actually a proposal to add specifically that syntax, the types, as comments to JavaScript. Similar to // or /* comments, those would be completely ignored by the runtime. They're just a way to describe your code. But TypeScript is more than that. It's more than just the new syntax. It's JavaScript with types. There's a type system. So what I like to describe instead is that JavaScript describes your code's values. You can describe, I have a variable, a class, a function, whatever. And TypeScript, on top of that, additionally allows you to describe the intent behind those values. You can say that this variable will only ever contain a string or number. That class's constructor is meant to be called with these specific types of things, which is not doable in vanilla or plain JavaScript. And just as an example of why we care about this, let's look at this beautiful function, log and call, takes in an action, logs, calls action, logs. Without some kind of type system, we don't know whether the way we are calling this function is correct, especially if this function is written in some NPM package or NuGet binary or whatever that we've downloaded. Fun fact, back in the day before NPM was really popular with TypeScript, people would publish JavaScript in NuGet packages. That's the package manager for C#.NET. We don't do that very much anymore. But if it's in some external code or you just don't have the time to read it, you don't know if, like, is the action required? Does it default to something? Are you calling it like with a string instead of a function? Like, is that what type, what shape are you supposed to call it with? If you're calling it right now, that's good, but what if it changes in the future? So we have four things that TypeScript provides us to fix that issue being lack of confidence in our code. First of all, there's the programming language I just mentioned. It's got that syntax, those types as comments. We'll see a bunch of those type annotations, type declarations soon. On top of that, TypeScript provides a type checker, which is a program, fun fact, written in TypeScript itself, very meta, that will take a look at your JavaScript and or TypeScript files, and it'll let you know you're mismatching. Either you said one thing here, but you gave it another thing there. On top of the type checker, we have the compiler, which is a tool that runs the type checker and also can be told to transpile or compile your code. Takes in your TypeScript files, poops out your JavaScript files and some build artifacts. And I know every language, every person uses the terminology differently, but the way I refer to it is that a compiler is a transpiler plus a type checker. That's how I refer to things. And then on top of the compiler, we have the language service, which is the thing that runs the compiler and type checker and stuff inside your editor. That's what tells VS Code or JetBrains, whatever's, to give you the little red squigglies when you mess things up. Or if you right-click on a variable and try to rename it, it uses TypeScript to figure out how to do that rename. 4 things that TypeScript provides. Yay, TypeScript. So if you want to get started, you don't have to do anything. TypeScriptlang.org/play is a nice online interactive playground. You type in JavaScript on the left or top side, and then on the right or bottom, depending on if you're mobile, there's the output. Also, you can view the errors, a bunch of other stuff. Alternately, if you want to get started locally, TypeScriptlang.org just has setup steps. These slides, which I will again mention for those who came in, which they are linked on joshokgoldberg.com. In the annotations for each of the following code snippets over the next, 20 minutes, there's a link to the TypeScript playground that pre-populates it with that code snippet. So you don't have to be furiously taking photos and typing the code out. But let's begin. What is TypeScript knowing? TypeScript understands the way that every construct or piece of code in your system is declared. You have a variable, its initial value is string. We now know that variable is a string variable. Later on, every time you use that thing, TypeScript will check to make sure, are you using it correctly? And just as an example, if you, let's say, have a string variable, yay, Sophia, and then you give it a number, well, no, wrong. That's not allowed. You can also have what's called a union type. And this, I think, is really cool. This is the start of where TypeScript starts to diverge from more traditional programming languages. This is totally valid and fine TypeScript code, at least the first few lines are. You can have a variable in JavaScript that could have potentially whatever types in it. Maybe it's either a string or a number. TypeScript understands that. The type union, or the term union, comes from mathematics set theory, which I personally have not dabbled in. But for the non-mathematicians in the room, cool. And if you try to call a method on something that is a union type, TypeScript will make sure that that method exists on all the things, all the types that your variable could be. Because if your variable is the 50% case of just the number, toUpperCase doesn't exist. So this is an error. But value2string, fun fact about JavaScript, exists on both strings and numbers. So that's allowed. TypeScript. The first bit of TypeScript syntax we'll cover is what's called a type annotation. Now, a lot of programming languages, such as C# have you say the type and then the name. var int myint or int myint. But TypeScript has it the other way around. TypeScript lets you declare the variable because in JavaScript there are now five different ways to declare a variable. There is var, let, const, and very recently using and await using. So we put the type annotation to the right. But what's really cool here is that this is telling TypeScript something it couldn't have inferred by default. TypeScript, if you didn't have the colon space string, would not have known what this value variable was supposed to be, the intent behind the code. By putting a type annotation, we've told TypeScript the intent. But that type annotation is just for TypeScript. If you compile this down to JavaScript, if you were to run this in the playground, what you would get is just the same thing without the type annotation. This is what we mean by TypeScript is a superset of JavaScript. If you take TypeScript syntax and remove all the TypeScript-specific stuff, you are left with JavaScript. With very few exceptions that are not covered in this talk, they're very controversial in the TypeScript community. Cool. I think this is really nifty. I think the general system of understanding intent and therefore checking your values, and then also the system of type annotations get erased, is like a really nice way to think about things. But let's up the intensity a little bit. I want to show you some cool stuff that like almost no other programming languages do. Who here has heard of unions and literals? The difference between literals and primitives? Almost, oh, I'm so excited about this. This is going to be great. In my book, Learning TypeScript, which I forgot to plug at the beginning, I start every chapter with a haiku and end every chapter with a pun or joke. This is the first of them. I'm just going to give you the answer. The next one you won't be given. Why are constant variables so serious? What was that? That's right. Thank you. They take themselves too literally. Union type annotations. If you have a variable that's supposed to be either a string or number, this is the syntax for telling TypeScript that it is a union type of string or number. That vertical bar piping is the or. And it's the same as before. If you try to assign a value to your variable that's not one of the allowed types, TypeScript yells at you. It's not assignable. That word assignable will come up more and more as you do more TypeScript. You will learn to hate it and then love it, hopefully. Now, narrowing, side note, I have a mild speech impediment around R's and W's. This is not a difficult thing for me at all. Narrowing is when TypeScript sees that inside an area of code, of the type of a variable or other value is more specific, it's more narrow than what it originally was declared as. Inside this if statement, TypeScript knows that the type of the value is definitely string. Because if it wasn't string, we wouldn't be inside the if statement. Which is why there's no type error here. And I'm actually going to, because I'm so far doing okay on time, I'm going to switch over to the playground. And let's go to TypeScript. lang.org/play, zoom in, shut up Microsoft. Let value equals math.random 123 or ABC. If you hover over, or in the playground, use this nice little 2/ syntax, it's called. You get these like little suggestions with your mouse. And then if you do if value type of value is string, you get type narrowing. How freaking cool is that? And again, this is all TypeScript type system theory. None of this is relevant to the code. We're not suddenly magically changing how your code runs in production. So I think that's really cool. That makes me happy. But it comes up a lot in TypeScript code. Another example of where it comes up is the difference between a primitive and a literal. A primitive type is the general classification of the primitives in JavaScript: string, Boolean, number. I did do a deep dive on Google for this one. You can also say that a value or a type is a more specific instance of that primitive, a literal. This value variable is not just any string in the world. It is specifically the string Bukvalno? Yeah? Okay. I got the like he's trying his best thumbs ups. Thank you. So if value is later assigned to that word I just said, that's okay. But if we try a different literal, a different example of string, not allowed. Because we're not allowing just any old string. We are allowing specifically Bukvalno, not Takova. Yeah, okay. Primitives versus literals. That explains the joke at the beginning of this section. And literals come up in a lot of places. It's surprisingly common in code to have a union type of primitive or some literal. For example, the result of a function might be string or -1. And TypeScript will prevent you from assuming that that function returns string. It'll let you know, if you're trying to use this value like a string, but it might have been a -1, you need to type narrow. And I realize that this example right here, string or -1, is very contrived. We're probably not going to use it. So I want to give you a more common one, string or undefined. Just curious, show of hands, who here's heard of the $1 billion mistake? Awesome, I love it. It's such a cool concept. The $1 billion mistake is the idea that C++, back in the day, I want to say, maybe it was C, I always forget, allowed you to put null or void star in places that were declared to be another type, which is why at the beginning of a lot of functions, you would have to say, if this argument is null, throw argument null exception. If that other argument is null. $1 billion estimated at least of damage to the software industry by people being allowed to put null in places that aren't allowed to take null. TypeScript and recent versions of C# and a few other languages solve that by saying, no, you silly goose, undefined is not a string. We might crash at runtime if you give me that. Also, for those who are not familiar with JavaScript, JavaScript is twice as good of a language as C#, that crap language, because we have 2 versions of null and you only have 1. That makes us not continuing that. So let's just quick example here. This one I will also give you. Spot the bug. Who here has used the built-in browser API prompt? One person. OK. So fun fact, the built-in browser API prompt returns type string or null, not string. So if you were to run this code, it might crash. If you were to check it in TypeScript, it will type error saying username is possibly null. TypeScript. Yay. Let's get to more complex things. This one I'm actually going to ask you all. How does a lawyer declare their TypeScript types? Anyone? I object. OK. I hope the content is good enough to overcome. TypeScript allows you to have values that are objects. If it didn't, it would be useless because JavaScript has objects everywhere. TypeScript will understand the type of something that is an object to be that same object type with whatever primitives or nested objects you use inside of it. Here, this const value is an object that has a property that's number and a property that's string. So you're allowed to say call value.name, value.power.toPrecision, but if you do value.nope, TypeScript knows that nope doesn't exist in the object. I'm going to refer to structural typing here and there. That's the technical term for how TypeScript's type system behaves. It's structurally typed. It looks at the structure of your things. You don't need to declare it. You don't need to say create an interface and then have the class implement that interface. It's all structurally based. If it works, it works. Which is the type system equivalent to how we describe JavaScript's runtime semantics, which are duck typed. Duck typing comes from the concept of if it looks like a duck and quacks like a duck, it's probably a duck. That's actual programming language theory. Cool. Similar to primitives and literals, you can use object type annotations in your code. You can say that my value will eventually be an object with name, string, power, number. And TypeScript will let you know if you assign an object that's missing something. The structure of what you're giving to it is not assignable. It's missing something. Words. Now, TypeScript has a type system feature called an alias, and I think we actually saw this in, I believe it was the keynote yesterday, using Scott equals system.int32. Very similar idea. Whenever I say name and power in this slide example, I'm telling TypeScript to cut and paste or copy and paste that object literal there, which makes types or type aliases in TypeScript kind of like interfaces in C# and similar, a way to describe the structure of something. And this is where we really diverge from other languages, both in that we have a terrible way of naming things, because I really hate having to say this name, but because this is incredibly powerful. The concept of a discriminated union. It is not bad discrimination. Discrimination is bad, but the mathematical concept of discriminating, meaning separating things out, is what this is based on. And I'm going to walk through these in order if I can get the animations right. We have two types here, which you can, again, kind of think of as like interfaces if you're a C# person. We have one that has variant name, the literal name, not string name, and the other variant power. And I'm declaring a union type of either name or power. So that when I declare this variable value, I'm saying its value is only ever going to be typed name value or power value. With me so far? Got a union type variable? Cool. And there's a 50-50 chance of its Josh name, 9001 power. And then when I ask TypeScript what type is value, TypeScript will tell me it's an object that has only one property known, which is either name or power. Which actually kind of makes sense. We don't know if it has name or power as the extra properties, but we do know either way it has the variant property, which is either name or power. So that's object typing. And if we narrow, if we say inside this if block, variant must be name, then TypeScript knows it can be narrowed to name value. How freaking cool is that? This comes up surprisingly often in TypeScript E code because people will write like a generic result type, which has a success, true or false, and then based on success, you either have an error or the actual data, like from a network request. Yay, type safety. Hooray! Okay. What makes a TypeScript project good? Come on. Fine. It should function well. Okay. Function parameters. I'm going to breeze through these because I'm running a little low on time, and this, to me, is not as interesting as the other stuff that's coming on later. You can annotate types of function properties. Here we have message string times number. You can also make them optional. That question mark indicates that TypeScript shouldn't consider it required. Otherwise, it would. Either way, TypeScript will still type check the assignability. If you pass a string to something that's declared as number, then what are you doing? You can also use default parameters. Kind of like with variables, you don't need a type annotation because TypeScript can tell the times parameter is type number. It's the primitive functions. We also have return types. You can declare what type of function is allowed to return, much like in basically every other typed programming language. TypeScript also has void, indicating I'm not going to return something from this. More on that later. TypeScript also has the return type never. Out of curiosity, anyone here work in a language other than TypeScript with a type called never? It's really cool. It's the concept of not only does this function not return anything, it doesn't return. It's a while true or a throw new error or raise exception, which is actually useful because TypeScript can tell you that that console log is unused. And this comes up a lot in tests, actually, and validation code, where if you say that, OK, this function returns never, it's just my helper for throwing an error, then you can type narrow with it. Here we're saying if input is falsy, we fail with, and TypeScript knows we don't have to add a return statement after the fail with, because fail with never returns. It is return type never, which means input on that last line is type string. Technically, we could consider input to be string excluding the empty string literal, but TypeScript doesn't have that feature yet. One day. TypeScript also has function types. You can declare that a particular thing is a function, which is important because in JavaScript, you can pass functions around anywhere willy-nilly. It's a first-class functions language is the term. Here we're saying that my getter variable is type string to number. Takes in a string, doesn't really matter that it's called input, it's just any input string, and returns number. So if I say that getter equals input return input, that's wrong, because input is a string. Spot the bug. This is an excuse for me to drink water. I'll give you a hint. I just spilled on myself. Sorry, AV people, if that breaks anything. So this is one of the advantages of TypeScript. I'm being rude to you, and I apologize for putting you all on the spot. One of the nice things about TypeScript is that it'll read your code for you and tell you the errors quickly, at least some of the errors. So in this one, we're using function types to say that the callback is a function that takes in string, text, and returns nothing. And then if we were to call a callback with, say, text and delay, TypeScript will let us know that, OK, you passed delay to callback instead of set timeout. Fun fact about set timeout in JavaScript, you don't actually have to pass in the number for it, but it's real weird if you don't. It just runs it immediately-ish, but not super immediately. Find me afterward if you want to talk about the async event loop in JavaScript and Node.js. It's wild. Anyway, what's a pirate's favorite data structure? You heard this yesterday. You know this. Arrays! Thank you. I love it. All right. Array types. This array is inferred to be a string array. Yeah? Good so far. It's actually much like C#. It can be inferred if it's, just the obvious, quote unquote. You can use a type annotation. In JavaScript, it's similar to many other In TypeScript, it's similar to many other languages. It's the type with the array symbol after it. Fairly straightforward. TypeScript has what's called a tuple type, which is somewhat similar to tuples in other languages. But in TypeScript, a tuple is a specifically known at specific indices array. We're saying that we know that this is not just any array. It's not an array of union type, string, or number. It is an array that has two elements. The first element is a string. The second element is a number. That is not the same as an array of string or number, because we know the first element is not a number. It's a string. The second is not a string, it's a number. Which means we can do really cool assignability checks here. Like if we say pair equals in an array, we know that, OK, the second one being a string is a type error. String is not assignable to number. I don't know how much tuple types come up in modern backend frameworks since I'm mostly full stack front end, aka front end. But here's an example of some front end code that shows how a lot of UI frameworks, who here writes React? Yeah, you do. Love React. Who here writes Preact or Solid? One person sitting in the back. You should check those out. They're really good too. They also have things like this, where we have a function, get state, set state, create state, whatever, that takes in the initial value and then returns a tuple of a getter and a setter, or the state and a setter. And this code only works without type errors because we've declared it's a tuple type. On line, the last one, we call get parentheses, and TypeScript knows get takes in no arguments, no parameters, because it's the tuple, the first element of that tuple. Without tuple types, we'd have no way of saying what the two returns are. It's a union of these two different function types. TypeScript. Awesome. Okay. This is not, I'm done with the jokes, don't worry. I want to move on to the miscellaneous section. We've got a few minutes, and I want to show you a couple of cool tricks you can do throughout your dev process with TypeScript. Because it's like a high five in your type system. The last time I gave this talk, I remember to ask someone to come up and high five me, and I'm sorry, I was going to ask and I forgot. First thing, IDE features. Who here uses VS Code? So many, awesome. Both the JavaScript and the TypeScript equivalents of this feature, and similar, are powered by TypeScript. So even if you're not a TypeScript developer, eat it, you're using TypeScript. I don't have enough time to show you in VS Code all of these, but if you right-click on something and then click Move to New File, TypeScript can move it to you and update imports and types accordingly. TypeScript can also find all references. Wish I had the time. Where you right-click something, find all references, it'll show you a list of all the places it's used. Or if you want to rename something, you can rename it, and it'll intelligently rename, which is different from running a find and replace in your source code, because if you want to rename something like ID, good luck finding and replacing that. Second up, I work on TypeScript ESLint, so I got to throw this in because it's freaking awesome. There are three common forms of static analysis. Your formatter, the fastest of them, the type checker, the slowest and smartest, and then the linter, somewhere in between. But with TypeScript fanciness, the linter is now type checked. To C# people, this is boring because your linter is already type checked. To JavaScript people, this is very exciting. And I want to show you an example of a linter rule that's only possible because of TypeScript syntax. Pardon me, because of TypeScript's type system. In JavaScript land, does anyone here know what happens if you await something that's not a promise or what we call venable? That's right, nothing happens, such as when I ask the audience a question. And in fact, we have a linter rule that can tell you you have an unexpected await of a non-promise, what the language calls venable value. Because console log returns void, nothing, ignore the result. This is a contrived example, so let's look at some even better stuff. Fun fact, we can auto-fix it for you. Let's take a look at this function. And I'll shortcut here, we don't need to stare at it. This onClick is a function that's typed as returns void, nothing, ignore it. So that's an unnecessary await. And there are two ways we could fix this. One is we could say it returns a promise. This is the syntax for a promise for void, which means it's cool with that. Or if you realize, if you look through your code and it's never actually provided an async function, only ever a synchronous one, we could remove the await. And if we remove the await, that means the set running true and set running false can be removed, which means the onClick and disable function does nothing, so we can remove that, which means the running state is actually unused, which means this button disabled, which, by the way, isn't even like the right way to disable a button. It can be removed, which means we can remove a third of our code thanks to TypeScript. Yes, TypeScript! I wasn't sure if there's swearing at this conference. Awesome. So let's recap all the things we went over, because broad overview, TypeScript, pretty cool. TypeScript's awesome because, as much as we love JavaScript, it doesn't provide a built-in standard syntax for declaring your intent. There are comments, but they're not standardized. There's union literal stuff in TypeScript, so it doesn't just have the basic primitives. You have object types, deep assignability, check in there. Function types, array types, awesome IDE features, and yay, TypeScript ESLint. Woo. If you want to learn more, all these things are free and open source online. That last one is my book's website, and I have a bunch of free projects. They're open source. Please report bugs if you find them. There are always bugs to practice TypeScript. I work on, as I mentioned, the linting tool TypeScript ESLint. We're the project that allows standard JavaScript tools to run on TypeScript code, including ESLint and Prettier. We're not backed by any major company, so we are very underfunded and understaffed. So please, contribute to us. You still have time for Hacktoberfest. Get your company to sponsor us. We'll put your logo on our website. And if you want to learn more about TypeScript, personally, I love books. That's how I learn. So if you like books, I wrote one. Hit me up if you are interested. Also, it's not in the slides, but Total TypeScript and TS for JS are two other ways of learning TypeScript that are great. One from Matt Pocock, the other Shonday Person. If you ever see him, tell him I said hi. Thanks, everyone. This has been fun.